Okay class, in last class we were doing the exercise 3A and we have done from question number 1 till question number 7, right, in our last two classes. And in last class I had also discussed some of the practice now questions. Now in today's class we are going to start with question number 8, exercise 3A. Bag P contains a red, blue and a white marble, while bag Q contains a blue and a red marble. The marbles are identical except for their color. A marble is picked at random from both bag P and bag Q. List all the possible outcomes of the sample space. Find the probability that the two marbles selected are of the same color, right? So first thing, you need to make the sample space. So I'll say that I have a bag P, and in bag P I have three marbles, red, blue and white. So I say that red, blue and a white marble, right? And in bag Q I have two type of marbles, that is blue and red. So I will make the bag Q with a black pen. So it is quite possible that if I pick the marble R from bag P, then I can pick the marble blue and the marble red from the bag Q, right? Same for blue. After the blue marble from the bag P, I can pick blue marble from the bag Q and a red marble from the bag Q. Similarly, for the white marble as well, I have two options. So the sample space is basically, I can pick red and blue, the first chain. I can pick red and red, red and then red, blue, 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 red, blue, 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 red, and the last one white, blue and white, red. It's the sample space that is asked in part 1. Sorry, that is the sample space only. Now in part 1 it says that probability of same color, right? So same color, it will be 1 and 2. There are only two possible options of the same color out of 1, 2, 3, 4, 5, 6. So it will be 1 divided by 3, that is the possibility of the same color, right? After that it says blue and red. Now here I am discussing a important point and I am going to write it down with a green pen, so listen carefully. In this question, order is not mentioned. And what does it mean, order is not mentioned? It can be blue or red, or it can be red or blue. It does not say in the question that the first marble must be blue or the second marble must be red. It is not mentioned. It is just said that blue and red. First marble can be blue, second can be red, or first can be red and second can be blue. So there are two possible cases, and when you have a possible cases, then you need to add them to find the final possibility. Now the possibility of blue red, it's only 1, right? So it's 1 divided by 6 plus the possibility of red blue, it's also 1. So 1 divided by 6, that is equals to 2 divided by 6, and last it will be 1 divided by 3, right? So that is your part 2. For part 3 it says different colors. Now can you use the concept of probability of all same colors plus probability of all not same color. So I am going to say same with the complement, that means not same, or you can say different, they both are same, is equals to 1. Can you find a probability of different colors by yourself? So it will be probability of all different, that is not same, is equals to 1 minus probability of same, that is 1 divided by 3. After taking the LCM, that is 3, it will be 3 minus 1, and that is equals to 2 divided by 3, and that is your answer, right? After question number 8, moving on to the next question, it's question number 9. Sorry. Yes, it's question number 9. Our 2-digit number is formed using the digits 1, 2 and 3. Repetition of the digits is allowed. List the sample space. So how many numbers can you form with these 3 numbers? So it can be 1, 1 because repetition is allowed, right? 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2 and 3, 3. These are the sample space. So that is your first part answer. In your next part, it says find the probability that the 2-digit number formed is divisible by 7. Now we are attempting B, first part. Now can you highlight those numbers which are divisible by 7? 11, no. 12, no. 13, no. 21, yes. 21 is divisible by 7. 22, no, 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 no. So that means we have only one number that is divisible by 7. Sorry, divisible by 3. I read the question wrong. So divisible by 3 means that I have 12, 21, 33 is also divisible by 3. That's it, right? So there are 3 numbers that are divisible by 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9. That means the answer is 1 divided by 3. Part 2. Perfect square. How many numbers are perfect squares? So I think there is not a single number that is a perfect square, so the possibility is 0, right? A prime number, a number that is not any factor except 1 and itself. So 11 is a prime number, yes. 13, yes. 22, no. 23, yes. 31, yes. That's it. So there are 4 prime numbers, right? So it's 4 and the sample space is 9. So 4 over 9. The last question, it's a composite number. Now before that, you must know what are composite numbers. Composite numbers are not prime numbers. In prime numbers, we have a condition that they have a factor 1 and themselves, like 7. Now 7 has 2 factors, that is 1 and 7 itself, right? So that is a prime number. But a composite number has at least 2 or more than 2 factors. Example, if I say 6 is a composite number because 6, apart from 1 or 6, it has the factors of 2 and 3, right? So a composite number is a number that at least one divisor other than 1 and itself. At least one divisor other than 1 and itself. Similarly, if you say 8 is a composite number because 8 can be divided by 2, 4, 1 and 8 itself. So apart from 1 and 8, it has 2 factors, and the composite number condition is that apart from 1 and the number itself is that it should be at least one more factors, right? Now in my question, how many composite numbers I have? So I'll say that I'm going to circle with the red pen, and 12 is a composite numbers because it can be divided by 2, 3, 4, 6. 21 is a composite numbers, can be divided by 3, 7, 1 and 21 itself. 22 composite numbers. 23 no. Now 23 is a prime number, it has only two factors, that 1 and 23, right? So we are looking for, you can say that, at least three factors. In short, if you summarize that, so composite factors are those numbers, composite numbers are those numbers which have at least three factors. 31 no, 32 yes, 33 yes. 33 can be divided by 1, 3, 11 and 33, right? So that means how many numbers I have? I have 5 numbers. So for part 4, my answer will be 5 divided by 9, right? I hope now you have clear about the idea of composite numbers, all those numbers which have at least 3 factors. Why I say 3? Let's suppose you are talking about 11. Now 11 has only 2 factors, that is 1 and 11 itself, so it is not a composite number. But if you talk about 21, so 21 comes from 1, 21 itself and 3 and 7, so it's a composite number, it is not a composite number. So composite number has at least 3 factors, more than 3 are acceptable. After question number 9, moving on to the next question, that is question number 10. I hope now you have an idea regarding the composite numbers and how we are using the sample space to find the probability, right? The question says, the 3 daughters-in-law of Mrs. Chen are happily awaiting the arrival of their bundles of joy within the year. List the sample space of the sexes of the 3 babies, given that the babies are equally likely to be either a boy or a girl. Hence, find the possibility that Mrs. Chen will have 3 grandsons, 2 grandsons and 1 granddaughter, 1 grandsons and 2 granddaughters. Now, first thing what you need to do is identify the sample space. At this step, I recommend you to pause the video, read the question again and then write the sample space. So it will be, we can say that all 3 babies are boys, right? Or it can be 2 boys and 1 girl, or you can say that boy, girl, boy, or it can be girl, boy, boy. Similarly, you can say that girl, 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 boy, girl, boy, girl, boy, girl, girl, right? So these are all the possible outcomes. Now you need to find the probability for first part, 3 grandsons. Now the possibility of 3 grandsons is valid only for one option, right? So it will be 1 divided by the sample space is 8. So the possibility that she will have 3 grandsons is 1 over 8. After that, second part, 2 grandsons and 1 granddaughter. Now again, in this question, sequence is not specified, that the first 2 are grandsons or the last 2 are grandsons or the last grandson. No, that means now we have a cases situation here, right? It says 2 grandsons and 1 granddaughter. So where we have this possibility, 2 grandsons and 1 granddaughter, 1, 2 grandsons, 1 granddaughter, 2, 2 grandsons, 1 granddaughter, 3, and 2 grandsons, 1 grand. Okay, only 3 cases are there for 2 grandsons and 1 granddaughter. So it will be 3 divided by 8, right? There are 3 possibilities, that 2 grandsons and 1 granddaughter. If the question asked in such a way that first 2 are grandsons and the last one is granddaughter, then you have only this result. First 2 are grandsons and the last one is granddaughter, then only one option. But in this case there is no talk about the sequence, right? So just 2 boys and 1 girls, maybe of any order. Okay, last part. 1 grandsons and 2 granddaughters. Again, no sequence, 1 grandsons and 2 granddaughters. I am going to solve this with the red pen. Now 1 grandsons and 2 daughters. 1 son and 2 daughters 1. 1 son, 2 daughters 2. 1 son, 2 daughters 3. Any other case? No. So it will be 3 divided by 8, and that is the answer of your part 3, right? So I hope now you have a clear idea how I solved the question, and it is an easy question, not a difficult one. Once you made the sample space correctly, then you can solve the questions easily. Moving on to the next question, it's question number 11. In an experiment, 2 spinners are constructed with spinning pointers as shown in your diagrams. Both pointers are spun. Each time the pointer is spun, it is equally likely to stop any sector, right? When you spin, equal chances to obtain a 2, 4, 5 and any number. Find the possibility that the pointer will point at the numbers on the spinners whose sum is 6. Now first thing, before starting the question, you need to plot the sample space. To make the question easy, what I will do first, I will draw the tree diagram, right? So first I am writing out the result of first spinner. So when I spin the first one, I can get either 1, 2, 3, 4, 5. So I will say that I can get 1, I can get 2, 3, 4 and 5. All possible options of first spinner. After that, when I spin the second spinner, then I will get the same result, right? 1, 2, 3, 4, 5. After 1, I can get these 5 values, right? Similarly for 2, 1, 2, 3, 4, 5. For 5 it will be 1, 2, 3, 4, 5. I am drawing like this way because of less space. 1, 2, 3, 4, 5. And the last one, 1, 2, 3, 4, 5. So that means that is my sample tree. Or you can say that if you think that it is difficult, then you can write your sample space like 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 2, 1, 2, 3. So it will be a grid of 6 by 6. So I prefer that this tree diagram is quite easy for me. But for you, you can write all the numbers 1, 1, 1, 2, 1, 3 and till then 5, 5. Now in part 1 it says that numbers on the spinner whose sum is 6. Now I am going to highlight those numbers whose sum is 6. So it will be 1 and 5. So 1 and 5 is 6. 2 and 4 is 6. 3 and 3 is 6. 4 and 2, and the last one 5 and 1 are 6. So how many possible outcomes I have? We are doing first part. So the possible outcomes are 5 divided by. Now the sample space. Can you identify the sample space? If you can, then it is good. If you cannot, then no problem. Look here. So the sample space are 1, 2, 3, 4, 5, 10, 15, 20 and 25. There are total 25 possible outcomes. If still you have a confusion, now listen. How come 25? 1 comma 1, yes, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 2 comma 1, 2 comma 2, 2 comma 3. So these all are the sample space. Similarly, you will do 5 comma 1, 5 comma 2, 5 3, 5 4, 5 5. So that's how you will get 25 sample space. And if you simplify it, so it's 1 divided by 5, that is your answer, right? So the first one is 1 over 5. Second one, the same numbers on both spinners. So possibility of same numbers. How many cases of same numbers we have? I am going to highlight it with the green pen. So 1 comma 1, that is 1, 2 comma 2, 3 comma 3, 4 comma 4 and 5 comma 5. So how many cases you have? You have 5 cases out of 25. So the answer is same, that is 1 divided by 5, probability of a same number. Part 3. Different numbers on the spinners. Now listen to me carefully. If I am going to find out the difference, so the sample space is 25, we know that, but the possible options are 1 2, 1 3, 1 4, 1 5, then 2 1, 2 3. So I need to count many possible options. Other than that, what I will do, probability of same numbers plus probability of not same numbers, and we say that not same means they are different, is equals to 1. You see that this concept saves you from the lot of working, right? So probability of different numbers, it will be 1 minus probability of same numbers. So 1 minus possibility of same numbers is, we have find out in part 2, it's 1 over 5. If you take LCM, it's 5, and it will be 5 minus 1, that is 4 divided by 5, answer, right? So instead of counting all the possible options of different number, what I have done, I just subtract the possibility of same numbers from 1 to get the possibility of different number. Keep in mind that probability of an event that it happens plus probability of the same event that it won't happen is equals to 1. That is the same concept we have studied in last classes, and the same concept I have applied in this part, right? So moving on to the next part, after third part, fourth one, two different prime numbers. Okay, so part 4 is two different prime numbers. Now first thing, I will write down two different prime numbers. So one is not a prime number, so I cannot include one here, because two different prime number, that means both must be a prime number. Now 2 is a prime number, so starting with 2, and I'm going to do it with the red pen. So first prime number is 2 comma 2, then 2 comma 3, then 2 comma 5. The three prime numbers of 2. If I talk about 3, so it will be 3 comma 2, and it says two different prime numbers. That means I cannot take 2 comma 2 and 3 comma 3. So I cannot consider this one, two different prime numbers. So 3 comma 2 and then 3 comma 5. 4 is not a prime number, so can't take it. 5 comma 2, 5 comma 3. So that means you have a total of 6 possible options, right? So the answer is 6 divided by 25. That is the answer of two different prime numbers. If instead of different prime numbers it says only prime numbers, then I will add 2 comma 2, I will add 3 comma 3, and I will add 5 comma 5. Since it is mentioned that prime numbers should be different, so I cannot take two prime numbers at a time, two same prime numbers. So that was your part 4. After that, what is the possibility that the number on the first spinner will be less than
the number on the second spinner. The number on the first spinner should be less than. Now the possible options are 1, 2. Yes, number on first spinner should be less than the second spinner. I am going to attempt it with a black pen. So the possible options are 1, 2, 1, 3, 1, 4, 1, 5. Number on the first spinner should be less than the second spinner. After that, now I cannot take 2, 1 or 2, 2 because number on the first one should be less than. So it will be 2, 3, 2, 4, 2, 5. For 3 it will be 3, 4 and 3, 5. 4 it will be 4, 5 and I cannot consider the 5. So for part B, possible options are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be 10 divided by 25. If you simplify it, so 5 2s are 10 and 5 5s are 25. So that is your answer, 2 divided by 5. So see how we are solving the question with the help of such possible options that we have written separately. So you can do it as well. It will make your solution easy, more logical, and you can find the possibility very easily. The most important thing to find the probability is about the sample space. If your sample space is wrong, that means all of your questions are wrong, right? So that was your question number 11. A bit lengthy questions. We have completed all the parts, how we are solving. One thing you need to understand how you solve these two parts. You see, first it asks about the same numbers and then it asks about the different numbers because they are interlinked, they are connected, right? So once you find the probability of the same number, subtract it from 1, you will get the possibility of different number, right? So moving on to the next question. So that is practice now question, and it's practice now number 5. The question number is 1. Michael is a darts player. There is an equal probability that he will hit or miss the bullseye. He aims for the bullseye and attempts 3 throws. Using a tree diagram, find the possibility that he misses the bullseye once. Now what is bullseye? If you ever see a dart game, so the center point, exact at the center, it's called a bull eye, right? So that is a bull's eye, right? Now it says that there is an equal possibility that he will hit or miss the bullseye. Now starting with the first one, that when he trying was the for the first time. So when he hit, there is an equal possibility that he hit the bullseye or he missed the bullseye. That was his first try. After that, again he have two options: either he hit the bullseye or he missed the bullseye. He hit the bullseye, he missed the bullseye. That is second turn. After that, once again, hit the bullseye, miss the bullseye, hit, miss, and then hit and miss. So that is a tree diagram for his 3 tries to hit the bull's eye. Okay, because it says 3 throws. If it says 2 throws, then we stop at the second, and if it says 4 throws, then we need to add one more. He misses the bull's eye once. Now what is actually happening? To make the question a little bit easier, I will write the outcomes here. So if you see the first one, hit, and hit. So I will say hit, miss. Hit, miss, hit. You are following the path, right? Hit, miss. So I wrote it down. Now hit, miss, hit. So hit, miss, hit, miss, miss, hit, miss, miss. Second one, miss, hit, miss, hit, miss, 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 hit, and miss, miss. Now what the result is portray? Basically, he tried the first one, hit, he tries the second one, hit, and when he tried the third one, he missed. So that your outcomes are showing the data when he hit the bullseye and when he missed the bullseye. Now the question says he misses the bullseye once. Only one time he missed the bullseye, or basically in part 1 it says 2 hits and 1 miss. So basically we are looking for 2H and 1M. Now there is no condition regarding the sequence that he hit the first one and missed the last one. No condition given like that. So you need to consider HHM. Now I'm going to highlight these scenario: HHM1, HMH, HHM. So I think that I have 3 outcomes, right? So for first part we have 3 options out of 1, 2, 3, 4, 5, 6, 7, 8 out of 8. So that is the possibility of first one, that he misses the bullseye once. The possibility is 3/8. For the second part, he hits the bullseye at least once. At least once means, we have discussed in last couple of classes that it talk about 1 miss. He hit the bullseye at least once. He hits the bullseye. So 1 hit you will consider, 1 hit you will consider, 2 hit you will consider, and 3 hit you will consider, right? So at least once means that you need to consider when he hit the target once, when he hit the target twice, and when he hit the target twice. Now I am going to highlight it with green pen. So 1 hit is there, yes. 1 hit is there, yes. At least 1 hit is there, yes. 1 hit is there, yes. At least 1 hit, yes. At least 1 hit, yes. At least 1 hit, yes. So that means the possibility is 7 divided by 8, that at least once he hits the target, right? So that is the practice now question, and it is a good question. I hope that in this question you have a clear idea how I plotted the tree diagram, because you see that once I plotted the tree diagram, it is very easy for me to write down the outcomes. So first step, if you completed your first important step, then you can complete your second step, and once these 2 steps are completed, to find the unknown probability is very easy, and you can see it by yourself, right? So I think that it is enough for today's class, the possibility probability, and I think that today is the third class of the topic probability. Keep in mind that probability in CIs comes in paper 1 and 2, right? Basically it covers a good portion in paper 1, right? And in paper 2 it combines with cumulative frequency and statistics, right? So probability comes with these 2 topics, and sometimes sets as well, right? So you need to practice probability. Keep in mind that probability tree is very important. Once you made the probability tree, then the outcomes, and once these 2 steps are completely done, then you can find the unknowns easily. Inshallah, in next class we are going to continue with the topic with more advanced level questions, in which we will deal with the replacement and without replacement questions. Keep in mind that till now there are no possibilities written on the tree diagram, right? So inshallah in next class we are going to start such questions in which there are possibilities on the tree diagram, and how you are going to calculate them we are going to learn in our upcoming classes. So see you in next class. Till then, practice maths and take care of yourself. Allah Hafiz.